I like to teach the dimensional analysis method as a process. So there's 5 steps that you go through. This can be confusing at first, but when you're working through problems, have these steps sitting there and take a very systematic approach, and you'll be able to use this process to solve many of the conversions that we'll be doing in chemistry. Because it's a series of steps, what you can't do is say, Mrs. Menard, I don't understand dimensional analysis at all, because I won't know where to help you or where to start. But you certainly can say, Mrs. Menard, I'm having trouble with step 1. I'm not able to place what is given. I can't figure out what is given into our railroad tracks. So you'll have to be able to tell me what step you're getting lost on. So I'm going to go through the steps fairly quickly, but we'll be doing these steps over and over. If you need to pause the video to write down the steps, please do so, because this will be kind of the foundation that you'll use until it becomes second nature. So the first step is to place what you're given in the railroad tracks, 1 unit per space. And the railroad tracks really are just a series of fractions, and the units are going to cancel. When we say 1 unit per space, if I'm going to try to convert 520 feet, and I want to get that to meters, then this 520 feet would go on the top, and it'd be understood to be over 1 because there's only 1 unit. Now sometimes maybe we want to go miles per hour to meters per second. And if you look here, when we talk about miles per hour, it's actually 2 units. So if I was going to plug in, let's say we want to change 45 miles per hour to meters per second, then I could put 45 miles on top over 1 hour. But it's only 1 unit, and if you're afraid that you're going to put something in this bottom spot when there's not a unit there, then just put it over 1, and it'll be fine. The next thing we're going to do is list all conversion factors needed to complete the problem. So we'll know that we're starting in feet, and we'll know that we want to get to meters, or we're starting in miles per hour and we want to get to meters per second. So we can find the conversion factors that we need to make those conversions, and we go ahead and write those down. And as we're learning this process, you're going to have to show each step of the work, and listing the conversion factors is part of that. Eventually, you won't have to list them anymore because it'll, again, will become second nature. But as we're learning the process, I do want you to write down and list all of the conversion factors that you're going to use. All right, then we're going to plug the conversion factors into the railroad track so units cancel. The units determine the placement of those numbers in the railroad tracks. So again, if I'm starting in feet and I want to get to, let's do miles since I already know that conversion. So I know that there are 5,280 feet, equivalent to 1 mile. When I go to plug in this conversion factor, which is going to go in this spot right here, feet is on top, so I have to put my 5,280 feet on the bottom with 1 mile on top. So I keep the conversion factor together as a fraction, making sure that my units cancel. All right, then we're going to multiply across the top, multiply across the bottom, and divide to get the answer. So that's how we do the math. And then finally, we'll give the answer to the correct number of significant figures, remembering that definitions and conversion factors are exact, so there's no uncertainty. The fact that there's 5,280 feet in 1 mile is a definition. We know that. And so the conversion factors do not limit your significant figures when they are a definition.